In this video, we're going to start to lay out some of the common reasons that we're going to see when we do proofs. So a proof you've seen is a two-column thing. In the one column, you have a bunch of statements, and for every statement, you need to have a logical reason that justifies its placement in the proof. So there are all kinds of different reasons, and we will uncover more and more of them over the course of the year. But I want to give us just a strong enough toolkit that we can get started with this. So right now, we're going to start with a bunch of reasons that you can identify just by looking at a diagram that they give you. We don't need to do any extra thinking about it. So let's take a look at a couple different proof diagrams. All right, so here we've got this figure here, and it says given that AB is congruent to CD, those two line segments, and we need to prove that triangle ABD is congruent to triangle CDB. We're not going to complete this proof in this video, but I wanted to show you that this is usually the kind of thing that you're going to see, either kind of listed like this, or it'll be given in a couple of sentences. So the first reason that we want to talk about is called given. So we can use given as a reason whenever there's a statement that they tell us in the statement of the proof. All right, so I can just copy AB is congruent to CD, and the reason for that is going to be given because it just said it right here. Another place that you'll often see statements that we can take are given is if you look in the diagram. So you can see that in this diagram, we've got these two line segments that have tick marks on them. So this has one tick mark and this has one tick mark. And that means that we can infer from this that these are that they are congruent sides. So we could also include, based on those tick marks, that AD is congruent to BC. And that would also be given. All right, so you can either see it by angles like that, or by tick marks in there, or by the statements in the proof. And just to give you a sense of some things, you can see tick marks in diagrams. We might have two angles that have single arcs like this, so we would be able to infer that those two arcs are congruent. Sometimes we'll see that angle bracket, which means that something is a perpendicular line. And the last thing, which you don't see as often, but it can happen, is if you see two lines with arrows pointed on them like this. This means that these two lines are pointed in the same direction. And so we can infer from this symbol that the two sides are parallel. So this is kind of an example of all of the different markings you might see on a geometry diagram and what you can infer based on that. A third thing that I want to talk about is just looking at this diagram. So AB is congruent to CD. I could mark that with two tick marks. Remember, I want to use a different number of tick marks because I want to say that these two are congruent, but they aren't necessarily congruent to these two. So I want to use a different marking to indicate that. So if I want to prove that these two triangles are congruent to each other, I could use SSS, except the third side is BD in both of them. So I can conclude this is another reason you can come up with. If you ever feel that it would be a useful thing to do, you could say that something is congruent to itself. And that's not given. It's obvious, but there's nothing that they told us that said that BD is congruent to itself. This is something that we will call the reflexive property. And if you want to be fancy, which IXL will do, it will be the reflexive property of congruence. All right, so this is the reflexive property of congruence because it's got the congruent symbol there. So you can imagine that on either side of this symbol are two things that are the same as each other. So it's kind of like if this were a mirror. So BD is looking at BD in the mirror, and they must be congruent to each other because of the reflexive property. There's also a reflexive property of equality. If I ever wanted to say that, say, x is equal to x, where x is some number, that would be the reflexive property of equality. But 99.99% of the time, we'll be talking about the reflexive property of congruence. All right, there is one extra reason that you can tell just by looking at a diagram, and that is if you've got two intersecting lines like this. So these two angles are these, we've talked about this angle relation before. These are called vertical angles because these two angles only share this vertex E. And we have talked about how we can conclude that angle AEC is congruent to angle BED. And this is going to be the reason we're going to call it the vertical angle theorem. THM for theorem. You can abbreviate words quite a bit as long as the person person who's reading it can be very clear of what you're talking about. So this is very clearly talking about the vertical angle theorem, and you could write it as vert angle thumb. And this is also enough information that somebody can tell that the reason that you're stating that these two angles are congruent to each other is because of the vertical angle theorem. All right, so for this first video, these are things that we don't need any other statements in the proof to justify. We don't need to know anything other than what's in the diagram. And these reasons are given. Either something is given in words or it's given through markings in the diagram. We've got the reflexive property, which says that anything is congruent to itself. And we've got the vertical angle theorem, which says that if you have two lines intersecting each other, that the vertical angles they form are congruent to each other. So being able to recognize these relationships when you see them in a diagram is going to be a big part of getting stronger with doing proofs. So we'll see how they work later on. But first, let's have a couple more videos where we fill up our toolkit with some extra justifications.